Okay, so today let's go ahead and take a look at the law of cosines, what it is, how we use it, and also why we use it, which I think is pretty important to understand that as well. So let's go ahead and take a look at this situation. First, let's look at the law, okay? The law is a squared equals b squared plus c squared minus 2ab times the cosine of A. Now, basically what you see there is the B and the C sides are the sides that you have, and the A side and the cosine of that angle are the ones that are together. So the A is over here by itself on this side. So whatever this angle is here, it's the cosine of that angle here. And the other two are the opposite sides. I'm going to show you what that are the adjacent sides, and I'm going to show you what that looks like with this setup. So we have a triangle. Let me get a better marker here. So we have a triangle, has sides 15 and 17. Again, that doesn't matter. That's just the B and the C, with the angle between them to be 40 degrees. And so we need to find the side opposite the angle that we have, which is x. So again, this x and this 40 are the two pieces in the formula that we're going to use. So basically what we're going to do here is just really pretty much plug this into the formula. Let's see if I give myself a little more room here. So now, why are we using law of cosines? Someone might ask that. Well, if we were to try to use law of sines with these given informations, we'd say cosine 40 over x. Well, we don't have that. And then 17 over this angle, or sine whatever this angle is over 17. Well, we don't have that either, so we would end up with two unknowns. And no matter which way we set this up, we cannot get 3 out of the 4 pieces for the ratios of the law of sines equation. We have only one angle here, right? So we can't use the angle sum formula to get the other angles. We have a missing side here, but it's not a right triangle, so we can't use Pythagorean theorem to get the third side either. So we are really forced into using the law of cosines. Now, you always want to check to see if law of sines can be used, because it's a much quicker formula. As you can see, we've got square roots and squares and stuff that we have to do. We've got some algebra, and a lot of mistakes can be happening in this formula. So I'm going to work through it, but I'm going to show you the complications that come up. So let's go ahead. So the side x squared is equal to a squared plus b squared, and these numbers do not matter which ones you use for which, because addition is commutative, and so is multiplication here. So that doesn't matter. 17 squared minus 2, 15 and 17. And I know I'm running off the page here just a little bit, but this is all the room I got. Times cosine 40. Okay, so we got x squared equal, 225 plus, I believe, 289 minus 2. Let's go ahead and work all this out just to get a bigger answer here. So, 15 times 17 times 2 is 510. Cosine 40. At this point, you could probably put the whole thing in the calculator. It wouldn't cause too many issues. So 225 plus 289 minus 510 cosine 40. And you get 123.32. Round that off. Okay, so now that's what x squared is. Now, obviously that doesn't make sense to this question because it wouldn't make a triangle 123 and 15 and 17. This would be way too big for a side of the triangle, but that's x squared, and we want what x is, so we're just going to square root that answer. So square root, answer, enter, and 11.1. When you square root both. And of course that's positive and negative, but for triangles we want the positive distance, so it's really just 11.1 units, whatever the units would be, and that's the length of this side here, 11.1. So there you go, and that does make sense, by the way. 40 degrees. It's kind of a acute angle here, so it is a little bit smaller. If this was like greater than 45, it would be open up wider, and it might actually create a longer side. But since this is a small angle, this is a small side. So just try to put some thought on that. Make sure that you are getting answers that make sense. Other than that, there's a good explanation of the use of law of cosines. And again, don't worry too much about the ABCs and C's. They give 3 formulas here, but just remember to match up the opposite side and the angle in this situation. Really all that matters in that formula. So I hope that helps, and if you have any questions, feel free to post them in the comments below, and thanks for watching.